right, corn children. This is lesson 6.1, part 3. Yeah, that's right. Area between two intersecting curves. Now, the one that's in the textbook is it's page 406. It's find the area bounded by these two curves, and they have -10 here. I am going to change this problem so that it's not as user-friendly when we do this by hand, and it'll be a -11. But I am going to use my calculator fully and completely to get the job done. So consider this a calculator-based problem. So if this is a calculator-based problem, the first thing I'm going to do is I'm going to go to my y equals, and I'm going to type these into y1 and y2. Now, you would not want to refer to these as y1 and y2 on the AP test. You would want to refer to them as f and g. But you can make a note to yourself that you have put f into y1 and you have put g into y2 so that you can keep them straight. But in all of our formal writing, we'll refer to them as f and g. So I've put them in there. I've graphed them up, and I've already set a window so that I can clearly see the points of intersection and the areas. And immediately we see something very interesting. There's two regions. Let me sketch this for you on paper so we can see it. The F curve, which is a cubic curve, does like so. And the G curve is our upside down parabola, which does like so. So we have two different regions that we have to account for. All right, so here's the idea. We have 3 points of intersection. Here, there, and there. I'm going to refer to them as A, B, and C. A being the x coordinate at A, B being the x coordinate of B, C being the x coordinate at C. So what we're going to end up doing is doing these two parts separately. Why? Because between A and B, it is the F curve that is top and G is bottom. But between B and C, now the G curve is on the top and the F curve is on the bottom. If the functions change, top, bottom, bottom, top, you have to set them up as two separate integrals. So in other words, to find this total area, I will need to integrate from A, capital A, to B, F on the top, G on the bottom, top minus bottom with respect to x. I would then add to that the second area, which would be the area from B to C. Now it is G on the top, minus bottom. So, two separate pieces. We are going to go ahead and find these points of intersection. Now, corn children, if you think about this at all, since every term has an x, this point of intersection is pretty straightforward. It is equal to 0. So that's pretty easy. I don't even need to store that. I could just use 0 up here and 0 down there. Now again, because I changed the problem from the textbook into an 11, these are not going to be pretty integers. I have made them purposefully ugly. So let's go ahead and figure out A and C, and let's remember how to use the calculator to effectively store these values. All right, so once again, I'm going to go to my calculator, and I have the two graphs on a window where I can see everything. I'm going to start by finding the A point of intersection. I will go into the calculate menu. So second key, calculate key, number 5, point of intersection. Now, I need to move my cursor. You'll have to find your cursor. It's on the screen. There it is. Near the first point of intersection. Whoa, a little too far. It's right there. I hit enter 3 times. Bada, bing, boom. Now, my point of intersection is negative 2.0186666, repeating. I need to take that number. Do not round it. I need to take the whole thing and store it. Here's how we do that. I just finished doing the point of intersection. I quit the graph. I'm at my home screen. I need to pull up the last answer. The last answer key is above the negative key in blue, so I use the second key and the answer key. It now says ANS. I will use my store feature, and I am storing this in alpha A. It's in there, I hit enter, there it is. We're going to do this exact same process on C. I go back to my graph. Campers, if you need to pause this and slow it down and do all of that, by all means go ahead. It's the calculate menu, it's number 5. Need to move my cursor, so I'm holding this down, I'm watching the cursor, can't find it, there it is. I'm moving it all the way over to the other point of intersection. When I'm near that point of intersection, I hit enter 3 times in a row. 1, 2, 3. My point of intersection is 2.08166, blah, 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 blah. So I'm going to store that one. Once again, quit the graph. Second, quit. I am now going to pull up the last answer. It will be the last thing I calculated. So the second key, the negative key down here, it says the last answer. But it's the last answer since we did work. I'm going to store that in alpha C. Hit enter, and there it is. It happens to be symmetric. Don't count on that always happening. All right, so we've got all this in there. Now, if we are wise, we should be able to type this whole deal at once. Now, if you're a little afraid, you can type this one, store the answer, type this one, store the answer, like store this in, I don't know, pick another letter, W, and store this one in Q or something, and then add them together. I'll do them one at a time. Now let's remember, we stored this equation in Y1 and this one in Y2, so I'm actually going to use those with my finint key. All right, so here we go. I'm going to go into finint. It's math 9, or there's a shortcut under the F2 shortcut key. I need to integrate from A, which is stored, to B, which is 0. I am going to put in y1 minus y2. Those are found in the F4 shortcut key, alpha, F4, y1 is right there at the top. I hit enter, minus, alpha, F4 shortcut key, scroll down 1 to y2, hit enter, arrow over with respect to x. Isn't that awesome? We hit enter. This is the first area. So again, if you want a 3 decimal place accuracy, I can store this, I don't know, I'll pick a letter. J, just cause. J, just. Yeah. Okay, so there it is, stored in there. We're going to do the second integral. The second integral is from 0, this one was 0, so I didn't store that one, to C, which is stored. But now it's y2 minus y1. All right, so here we go. Again, alpha F2 has the shortcut menu. There's finint number 4. And I'm going to integrate from 0 to alpha C, the stored value, no rounding. Arrow in, alpha F4, y2, scroll down to it, hit enter, minus alpha F4, y1, hit enter. With respect to x, we get this answer. Yes, they happen to be equal. Don't get too excited. They're not always symmetric. I will store that one. Now you have to remember you stored the other one in J, so don't use that. I'll use K, just because. And then our final answer would be alpha j plus alpha k. That one you can either truncate or round to 3 decimal places. Now, as far as the work we would need to show, we would want to show where we got these values and what they were. So I would want to show that I set f and g equal, and I got A, which is, oh, I totally forgot what that was. It was negative 2.08, something repeating. And at B, which is 0, and at C, which was positive, whatever that one was, 2.0, what the heck was it? Alpha A, 0, there's a 1 in there, 16, 2.0816 repeating. So I'm showing whoever's grading this how I got these answers. I'm finding points of intersection. I have now labeled them. I would need to show what the limits of our integration are, and I would not need these, but I would do f minus g, g minus f. So I'm showing the proper notation with the proper limits. Once you have that information, everything else is done on the calculator, and all we have to crank out in the end is that that area, I wouldn't use A because A is already in here, that area is 3 decimal place accurate, 28.16, either round or truncate. Calculator's a beautiful thing, people. There it is.